Okay, electrons in a microscope are accelerated through 12.8 volts. What de Broglie wavelength will they have? Well, I know that I'm going to use V times E is 1/2 mv squared and get the velocity, right? That's the velocity. This is the accelerating potential, right? Then I'm just going to go and plug that in. I'm going to say momentum is h over lambda, right? And then that momentum is mass times velocity, right? So that's Planck's constant over the wavelength. And then I can get the wavelength, right? Wavelength is equal to Planck's constant over mv, right? Okay, so let's use this equation and figure out what that velocity is, right? Okay, so the velocity is going to be 2VE over m, right? That's the velocity squared. So multiply by 2, divide by m, and then square root, right? Okay, so that equals the square root of 2 times 12.8 times 1.602 e minus 19th, right? Divided by 9.11 e minus 31. That's the mass of an electron, right? We've got to look that up in our data packet. So let's go square root of left parenthesis 2 times 12.8 times 1.602 e minus 19 divided by 9.11 e minus 31st, right parenthesis. Okay, my velocity, very unhelpfully by this TI calculator, is 2121739.44. Okay, so let's see, what would that be if we had a well-made calculator that give me scientific notation with one press of a button. That would be, what is that, 2.12 times 10 to the 6th or something like that, right? That's something I'm just happily going to store in A. Okay, and now I'm all set. I'm going to use this guy here, right? The de Broglie wavelength is Planck's constant over mv, right? So that's 6.626 e minus 34 divided by 9.11 e minus 31 times that velocity, right? 2121739.44, right? Okay, so let's do that. 6.626 e minus 34, okay, divided by 9.11 e minus 31 divided by alpha a. Whoops, I just did something weird. Okay, let's go second entry. Okay. Apparently I'm bad at this. Okay, 6.626 e minus 34. Okay, divided by 9.11 e minus 31 divided by alpha a. And I get 3.428 times 10 to the minus 10th meters. Holy cow, that's really small, right? That's like 3 atomic diameters, right? Much smaller than, that's like 0.34 nanometers. Remember, visible light is 400 to 700 nanometers, right? So this is like way smaller than that, right? Better resolution.